Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The endeavour commenced with a question concerning the influence of the medium's motion on the velocity of light, propounded by Albert A. Michelson and Edward W. Morley in their 1880 publication. This essay endeavours to furnish a meticulously detailed evaluation of that work's internal claims, arguments, assertions, and specific findings presented in a section-by-section manner. The central focus remains the rigorous assessment of the internal logic, evidence presented, and the theoretical underpinnings within the confines of that critical scientific contribution. Section 1: Introduction and Statement of the Problem. The work begins with a concise introduction clearly stating the central question that the authors proposed to address. The authors outline the necessity of investigating whether the luminiferous ether, the hypothetical medium supposedly permeating all space and through which light was believed to propagate, would influence the speed of light, as observed on a moving Earth. The core inquiry revolved around detecting the expected effects of this motion relative to the ether. It acknowledged previous attempts to measure the Earth's motion. Mentioning the inability to detect definitive evidence, the authors posited that either the ether's motion was influenced by the Earth, or the methods were inadequate. The crucial issue was the necessity to determine if a variation in the velocity of light could be detected due to the presumed relative motion. This established the foundational goal and framework of the research. Section 2: Theoretical background and previous experiments. The paper moves on to discuss the prevailing theoretical framework, specifically the wave theory of light and the necessity of a medium for wave propagation. It elucidated the concept of the luminiferous ether. It then provided a review of prior attempts to measure the Earth's motion relative to the ether. These attempts, principally reflecting efforts by Fresnel, Arago, and Fizeau, are referenced. It highlighted that such measurements did not present an unambiguous detection of the Earth's motion through the ether. The authors referenced the theoretical consequences of a moving ether, specifically the expectation of a change in the velocity of light dependent on the relative motion of the observer and the ether. The discussions here are succinct and focused on setting the stage for the author's own experiment, which was to improve the sensitivity of the measurements. Section 3: The principle of the interferometer. The paper describes the Michelson interferometer. This is a central element and crucial methodological innovation, described as the instrument used to measure the predicted variations in the velocity of light. The principle involves splitting a light beam into two, sending these beams along perpendicular paths. The two beams are then recombined. The interference pattern produced is analyzed. Shift in the interference fringes would indicate differences in the light's travel time along the two paths. Michelson and Morley explain how any change in the velocity of light along one path, because of motion through the ether, would cause a detectable shift in the interference pattern. This section carefully elucidates the theoretical basis for using the interferometer to detect changes in the velocity of light. It is a crucial explanation for the experimental methodology. Section 4: Apparatus and experimental setup. The authors provide a meticulous description of the experimental apparatus and, specifically, how it was constructed. This section details the specifics of the light source, beam splitter, mirrors, and the means of adjusting and aligning the apparatus. It is emphasized that the instrument, notably the interferometer, was mounted on a substantial stone base to minimize the effects of vibrations. This carefully addresses one of the critical sources of noise. The procedure for mounting the device, including the use of mercury to float the stone base, is meticulously detailed. Specific attention is given to all aspects of the apparatus, from the optical components to the mechanics for rotating the interferometer device. The description highlights the author's commitment to experimental precision. Section 5: Experimental procedure and data collection. This section describes the experimental procedure, detailing the steps taken during the data collection process. The procedure for adjusting the interferometer to obtain interference fringes is detailed, including the adjustment and alignment of the mirrors, the method of rotating the interferometer through different orientations to measure the predicted time differences is elaborated, the method of observation and how the fringe shifts were recorded is described. The author specifically explains steps taken during the experiment, the specific settings of the apparatus, and the methods of observation. The emphasis is on reproducibility and the detailed recording of data. Section 6 Results and Observations. This section presents the experimental results, including the observational findings. The key result is the absence of any detectable fringe shift. This directly implies that there was no measurable variation in the speed of light attributable to the supposed motion of the Earth through the ether. This directly contradicts the theoretical expectations based on the assumption of a stationary ether. The authors discussed the precision of their observations, meticulously specifying the degree to which they were able to detect a fringe shift. This is a critical discussion, because it is here that the core findings are presented. The results are expressed both quantitatively and qualitatively, emphasizing the consistency of the observations. Section 7 Discussion and Interpretation. This section addresses the implications of the experimental results and their interpretation. The most striking conclusion of the experiment is that, within the limits of experimental precision, there was no detectable influence of the Earth's motion on the velocity of light. The authors discuss this in relation to the theoretical expectations and the prevailing ideas of the time. They explore potential explanations for the null result. The discussion acknowledges the significance of the findings. They reflect upon possible refinements to the experimental setup. The authors do not definitively conclude the ether's existence or non-existence, but rather, they emphasize the absence of a measurable effect. Section 8 Conclusion. The conclusion provides a concise summary of the work's principal findings. It reiterates the experimental result that the Earth's motion, as ascertained by the experimental apparatus, does not appear to exert a measurable influence on the velocity of light. The conclusion underscores the significance of this finding in relation to the prevailing theoretical frameworks and the necessity of further investigations to clarify the phenomenon. The conclusion conveys the meticulousness of the experimental approach and the clarity of the results. It acknowledges the importance of the experimental technique. Section 9 Critical Evaluation of Claims and Arguments. The core claim is that within the bounds of sensitivity of the interferometer, no change in the velocity of light was detectable. This is a foundational, empirically driven claim. One must critically examine the internal consistency of its foundation. The experimental design is meticulously presented, allowing for thorough analysis. The argument relies on a carefully constructed experimental apparatus combined with a clear theoretical framework. The interferometer is designed to detect minute differences in the travel time of light. The argument hinges on the sensitivity of the apparatus, the accuracy of measurements, and the absence of systematic errors. The results are presented in a way that is consistent with the initial hypothesis. The methodology clearly supports the claims. The authors present a clear and transparent account of their procedures. The experiment rigorously adhered to the expected standards of scientific inquiry. The argument, therefore, is sound by the author's design and is difficult to question. The limitations of the experiment are acknowledged. The interpretation is conservative. Section 10 Methodology and Underlying Assumptions. The methodology is central to the entire work. The use of the interferometer represents a major advancement in the field of optics. The underlying assumption here is the ether's existence. The experiment is designed to detect changes. An underlying assumption is that the ether's motion should influence the speed of light. This is based on established theories. The interferometer's design reflects the theory of light interference. The authors presuppose the validity of wave theory. The experiment's design is contingent upon the principle of superposition. The meticulous attention to experimental detail is key, as is the calibration of the apparatus. The statistical analysis of collected data is thorough and shows the care taken in the experiment. These reveal the reliance on standard scientific practices. The implicit assumption of repeatability is evident. The whole design displays the core tenets of scientific methodology. Section 11 Evidence and supporting data. The evidence presented in the work is derived from meticulous observation and precise measurements. The data is presented as a clear absence of any fringe shift. Specific details are provided about the level of precision. The authors clearly state the degree to which they were able to detect fringe shifts. The results are presented not just quantitatively, but also qualitatively. The authors emphasize the consistency of the observations, building confidence in the results. The evidence, therefore, is based on empirical observations. The supporting data is the careful description of observations. The lack of observed fringe shifts comprises the most pertinent evidence. The details of the experimental apparatus further bolster the validity of the evidence. The absence of measurable variation is the foundation of the evidence. Section 12 Internal coherence and logical consistency. The work exhibits a high degree of internal coherence and logical consistency. Each section builds systematically, providing a logical flow of ideas. The theoretical background is clearly articulated. The principle of the interferometer is presented. The experimental setup and procedure are detailed, leading to the presentation of experimental results. The interpretation of the results is consistent with the experimental observations. The authors acknowledge the implications of their findings. There is internal coherence throughout the piece. The authors acknowledge earlier experiments, which provides additional context for the findings. The experimental design is directly linked to the theoretical framework. The lack of an observed fringe shift logically contradicts the initial hypothesis. The authors systematically explain the logic, the argument. Thus, presents a cohesive internal structure. Section 13 Potential limitations and weaknesses. One potential limitation stems from the inherent sensitivity of the apparatus. Despite the meticulous design and careful construction, there is always the possibility of undetected systematic errors. Although the authors went to considerable measures to eliminate or mitigate these, such aspects can never be completely eliminated. The possibility of a complete absence of the expected effects remains inherent within the scope of this work. Also, the interpretation relies on the understanding of the ether's properties. If the ether possessed properties different from what was presumed, the author's conclusions could be influenced. The theoretical models that were available at the time were limited in their ability to describe all the phenomena. This is a consistent limitation. Section 14. Historical context and intellectual landscape. The work appeared in a time of active inquiries into the nature of light and electromagnetism. The paper exists within the context of the wave theory of light in competition with the particle theory. The author's work appeared during the period when James Clerk Maxwell's work was being consolidated. The prevailing view was the ether, a hypothetical medium. The study was undertaken in light of the earlier efforts of Fresnel and others. The work both reflected and shaped the intellectual landscape. The paper engaged with prior experimental efforts. It was designed to address perceived weaknesses in earlier designs. Section 15 Contemporary reception and subsequent revisions. The paper immediately began to generate considerable attention. Some scientists struggled to reconcile the observations with the existing theories. The null result was initially perplexing, because it challenged the established understanding of the ether. Further experiments, done with similar apparatus, validated the findings. Those experiments added further weight to the paper. It catalyzed further research into the nature of light. The work led to the development of alternate explanations and a complete shift in understanding. The experiment helped bring about the theory of special relativity. The results became key in the advancement of modern physics. Section 16 Applications, Implications, and Significance. The work's significance is considerable. The paper profoundly challenged and eventually overturned the prevailing understanding of space, time, and motion. It demonstrated that the speed of light remains the same. It has since become a cornerstone of modern physics. The primary implication is that the ether, as it was then conceived, did not exist. It helped create a new understanding of how these values are defined. Relativity and its consequences stem from this experiment. The experiment had tremendous impact on the trajectory of physics. The implications extend far beyond the immediate findings. Section 17 Synthesis and Summary of the Evaluation. In summary, the 1880 paper by Michelson and Morley presents findings of significant value. The experiment established a standard against which the ether could be measured. The design of the interferometer is a great achievement. The work met the highest standards of scientific rigor. The findings are supported through meticulous observations. The paper's internal claims are well supported by the methodology, experimental design, and collected data. The work's logical coherence is remarkable. The authors acknowledge the limitations and implications of their work. The historical context and intellectual landscape contributed to the work. The paper presents one of the most important experiments in the history of physics. The enduring impact is evident. The scientific community has recognized the importance of these findings. Section 18 Conclusion Enduring Significance. Michelson and Morley's work, in its entirety, remains an exemplar of scientific inquiry. The study serves as a paradigm of meticulous experimental design, carefully presented data, and judicious interpretation. The study provided the foundational empirical evidence that ultimately challenged the concept of the luminiferous ether and, by implication, paved the way for the development of Einstein's theory of special relativity. The implications of the experiment extended well beyond the initial scientific concerns. The study initiated a fundamental shift in the world's understanding of space, time, and the fundamental laws governing the universe. Its enduring significance resides not only in its specific results but also in its methodology, its approach, its commitment to empirical observation, and its profound ability to provoke a re-evaluation of fundamental scientific assumptions. The paper's impact remains significant, testament to the power of careful experimentation and the pursuit of scientific truth. The work's place within the history of science continues. It exemplifies the transformative nature of scientific inquiry.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.